What do you call a news article that reports the death of a satellite? An obituary! Hey guys, welcome back to the Stimulus. I'm Steph, and this week we have a special edition This Weekend STEM. Because there was so much really awesome STEM news this week, I decided to split it up in two videos, which may be overambitious, but hey, we're gonna go for it. So this video consists of only space STEM news, so if you're not a space fan, then skedaddle. And why? Because it's awesome! But if you're one of my space tweeps, welcome, sit back, relax, and here's what happened this week in space STEM news. Our first story of the week deals with a cosmic Walking Dead scenario. NASA's X-ray Space Telescope, the Nuclear Spectroscopic Telescope Array, or NuSTAR, has detected what may be a massive stellar graveyard at the center of the Milky Way galaxy. A research team from Columbia University used NuSTAR to take a look at an area at the center of our galaxy that's approximately 12 by 12 parsecs. Yes, parsec is a unit of distance, not a unit of time. Really, Lucas? You could go back and change it so that Greedo shot first, but you couldn't fix the parsec line? God forbid Han Solo looked like a cold-blooded killer, but we had to leave him looking like a scientifically incompetent idiot? Rant complete. To put it in units that you might be more familiar with, 12 parsecs is equivalent to about 40 light years. Typically, when researchers looked at this region of space, they would see low-energy X-rays. However, when they looked this time, they saw something very different.
According to Kirsten Perez, the lead researcher on the team, as you go to higher and higher energy X-rays, the emissions from these low-energy emitters dies off. But we were still able to see another emission component underneath all that, and we don't quite know what it is yet.
Astronomers have several theories about what could be causing these high-energy X-rays. The most popular theory involves pulsars, or collapsed remnants of stars that literally went out in a blaze of glory, also known as a supernova. Pulsars are kind of the equivalent of stellar zombies, although rather than eating brains, they leech off the energy of their neighbors. Pulsars are capable of spinning incredibly quickly, and when they do, they emit radiation similar to what was detected by NuSTAR. Another type of undead but pretty much dead star that could be causing this kind of radiation is known as a white dwarf. The big difference between white dwarfs and pulsars are white dwarfs are not large enough to go supernova, so instead they just get super dense and have very strong gravity. Our sun will become a white dwarf in about 5 billion years, give or take. The incredibly strong gravity is what can emit the kind of radiation that NuSTAR detected. Another theory involves small black holes. As they feed off their companion stars, they also emit high-energy radiation. The final and less exciting theory of the four involves cosmic rays. Now, if you recall, a couple weeks ago, I covered a story about cosmic rays, and if you click this link right here, it'll take you back to that episode of TWISTEM. Now, in this theory, cosmic rays are emitted from the supermassive black hole at the center of the Milky Way galaxy. When they interact with the super dense gases in the Milky Way, they produce the high-energy X-rays that the researchers saw. None of these theories match up with previous research, so the team still plans to continue looking at this particular area of space in the hopes that they can determine the source. While cosmic zombie stars may not be coming to munch on your medulla oblongata, new research indicates that space can still have negative impacts on the human brain. Now, this research is just one study among many that NASA is currently performing in order to determine the effects of long-term spaceflight on the human body. If you recall, a couple weeks ago, I covered a story in TWISTEM about astronauts Scott Kelly and Mark Kelly. Scott is currently spending a year on the International Space Station. While he's up there, NASA will be studying the effects that space has on his body and comparing them to his brother Mark, who's still here on Earth. And if you want to refresh your memory about that story, click this link and it'll take you to this story. The research that we're focusing on for this episode of TWISTEM involves the effects of radiation on the human brain. Now, before you freak out, there is no reason to panic for the astronauts on the International Space Station. The ISS sits at a low enough altitude to where it's protected by Earth's magnetosphere, so the astronauts are shielded from most of the harmful radiation. In addition, the astronauts wear dosimeters, which tells them how much radiation they've been exposed to. Once their radiation exposure reaches a certain level, the astronauts are no longer allowed to fly in space. Radiation exposure becomes a big problem for deep space missions like the one that NASA really wants to send to Mars. Then, astronauts are no longer going to be protected by the magnetosphere, so they're going to see a lot more radiation. For this study, researchers at NASA's Space Radiation Laboratory exposed lab mice to radiation levels that would be comparable to what the astronauts will see once they start deep space missions. For the experiment, they used fully ionized oxygen and titanium, which is frequently found in cosmic rays. Each mouse was hit with a single beam of charged particles in order to mimic the small doses of radiation that will penetrate the spacecraft's hull as it traverses the solar system. 6 weeks after exposure, researchers at UC Irvine started to notice two major negative impacts. The first thing that they noticed was that the mice's brains had become inflamed, and this was disrupting neuron communication. Apparently, as the charged particles penetrated the mice's brains, they severed dendrites, which pass electrochemical signals back and forth between neurons.
The picture on the left shows a mouse brain prior to radiation, and as you can see, there's a pretty large difference from the picture on the right, which is after the radiation.
To give you an idea of how serious this is, this effect is typically seen in Alzheimer's patients. The second major issue emerged when researchers performed behavioral tests on the mice. They noticed that they were less curious and more easily confused. This type of effect is typically seen in brain cancer patients that are undergoing radiation treatment. While these findings are very problematic, they are by no means the nail in the coffin for deep space exploration. Researchers are already looking into ways to beef up the shielding on spacesuits and spacecraft. Since there's no way to completely shield yourself from radiation exposure, the researchers that actually worked on this study are trying to come up with a way to help protect against neuron damage. Hopefully, science can come up with some sort of mitigation soon, because we all know that that Mars 1 mission is definitely happening, like, soon. Moving on to slightly less Debbie Downer space news, on Wednesday, Blue Origin completed a successful test flight of its new Shepard rocket. If you haven't heard of Blue Origin before, don't feel bad. They've actually been flying under the radar for quite a while. In fact, they've been around since 2000, which is way before SpaceX and Virgin Galactic were even a thing. While they may not be well known, they are certainly going toe-to-toe with the big guys. In fact, like SpaceX, Blue Origin is also trying to develop a reusable first stage rocket. Unfortunately, also like SpaceX, Blue Origin was unable to land its reusable first stage on Wednesday. Overall, the test was still pretty successful. They were able to fly the rocket to an altitude of 307,000 feet, or approximately 58 miles. In addition to testing their rockets, Blue Origin has also been testing their crew capsule escape system. In the event of a catastrophic failure, this system will jettison the crew capsule safely away from the rocket. So what's next for Blue Origin? Future plans include improving their hydraulic system, which the first stage failure was attributed to on Wednesday. Additionally, Blue Origin also has 2 more rockets in production. Future tests are expected to focus on scaling up the rockets and sticking the first stage landing. As space technology progresses and we beckon in new hardware like New Shepard, we also have to say goodbye to a few familiar faces. I can get through the story without getting emotional again. I can do this. Thursday, at approximately 3:26 p.m. Eastern Time, NASA's Messenger spacecraft slammed into the surface of Mercury, going approximately 8,750 miles an hour and ending its 11-year mission. Messenger was launched in August of 2004, and after flying all the way across the solar system, it inserted itself into orbit around Mercury in March of 2011. While Messenger's primary mission was completed in 2012, the mission life has been extended twice, allowing researchers to gather thousands of pictures and videos of Mercury. The data gathered helped researchers determine the composition and the history of the planet, in addition to confirming that there's ice on the polar caps and organic material. Unfortunately, Messenger ran out of fuel several weeks ago, so the mission scientists decided that it should go out with a literal bang. While we were unable to see Messenger strike Mercury's surface since it happened on the side of the planet facing away from us, we estimate that the crater was approximately 5 times the size of the spacecraft. As scientists and space fanatics alike watched Messenger's signal dwindle and then disappear, kind words were sent out all across the internet wishing the little spacecraft well.
On Thursday, Sean Solomon, Messenger's principal investigator, stated, "Today we bid a fond farewell to one of the most resilient and accomplished spacecraft to ever explore our neighboring planets. The Messenger mission has surpassed all expectations and delivered a stunningly long list of discoveries that have changed our views, not only of one of Earth's siblings planets, but of the entire inner solar system."
So that ends our very special edition of This Week in STEM. I hope I can manage to get the second video up without losing my absolute mind. Don't forget, if you guys are super into the sciencey, spacey stuff, feel free to give this video a big thumbs up and subscribe to the channel. Also, if you want to check out any of the stories I covered or some of my social media, I will include links to that down in the description below. Don't forget, throughout the week, if you find any really cool STEM news stories that just happen to tickle your fancy, feel free to send them over to me on Twitter at StephEbs43 using the hashtag TWISTEM, and they might just make it into next week's video. So with that, I'm going to go wipe down my whiteboard, outline the next show, and shoot it hopefully all in like the next 45 minutes. So, see ya! Spectroscopic. If I can't nail this, it's going in bloops and we're done. Or a new star that has a... Researchers looked at this region of space, they would see high... low. It's not low, it's high. Pulsar. Now in this theory, while cosmic zombie stars may not be coming to munch your medulla, you know how to say that. The ISS sits at a low enough altitude to where it's protected by Earth's magnet. I burp a lot on camera. I'm sorry, I'm really not that gross. You just see it. Each mouse was hit with a single beam of charged particles in order to mimic the small doses of radiation that will penetrate. Dang it! Is at UC Irvine, it's Irvine. Crap, sorry, California. Shield yourself from radiation exposure. Please shield yourself from radiation exposure. God, why can't I say that word? Exposure. I got this. Origin completed. Origin completed a successful test flight of its rocket Blue New Shepard. Why is my brain just farting on me right now? Like literally brain farts just everywhere.